Okay, let me discuss few questions from the specimen question paper which is uploaded in the ISC website. Okay, related to AC. I will go by each chapter if it is possible. So, question number 5 is there related to AC. Which of the following is not the characteristics of resonance in an LCR circuit, series circuit? See, now you may have understood. They have given options. XL is equal to XC, then L omega is equal to 1 by C omega, then F is equal to 1 by 2 pi root of 1 by LC. So you can write it like this. Then the third option, one option is given like this. 2 pi Fc equal to 2 pi Fl. So this is wrong because it is x. If XL is equal to X is correct, L omega is equal to 1 by C omega, that is also right. F is equal to 1 by 2 pi root of L by C, that is also right, because when this becomes equal, then it will be uh, L omega will be 2 pi Fl, the other will be 2 pi Fc. So F squared will be equal to 1 by 4 pi squared LC. So F will be equal to 1 by 2 pi root of LC. But this is wrong. They are not equal like this. So hope you understand. This is one from the resonant part. Then question number 6. Let me check the question paper. Question number 6. A graph showing variation of impedance Z of a series LCR circuit with frequency of the alternating EMF applied to it is shown. What is the minimum value of this impedance? I think there is a graph something like this. What is the minimum value of the impedance? See, when the impedance is minimum means, I already told you, when x in that equation Z is equal to root of R squared plus XL minus XC the whole square. Z will be minimum when this becomes 0. So that will be equal to root of R squared. That will be equal to R. So this question's answer will be equal to R. Hope you understood. Anything related to this you can do like this. Okay. Then question number 21. See, there is a graph given to find the frequency. I think you can see directly when it is getting repeated. So the t is given here. When you just check when it is getting repeated, so this much becomes the time period. And I told you frequency is equal to 1 by t. So this is some 0.10 seconds. So time frequency will be equal to 1 by 0.1. So it will be equal to 10 hertz. So because this again repeats, so how much time it is required for one complete oscillation is time period. Frequency is 1 by t. So you get the answer. Uh, then question number, this is question number 21, 26. See, in that question, one second, I'm not able to open it. In that question, I think it is given like this. E is equal to 200 times sine 100 pi times t. See, normally one question will be like related to this. They are asking you to find what is the frequency. See, if you compare this with the equation E or V, same thing. V is equal to V0 sine omega t. Now, this is V0, this is sine 100 pi comes in place of omega and t. So, you can write omega is equal to 100 pi. Omega is actually 2 pi f. So, 100 pi. So, f will be equal to 50. Pi and pi cancels, you will get 50 hertz. So one question can be something related to this. Easily you can do. Okay. Then how question number 34, how to reduce the loss of power in a transformer. So lamination is done to reduce the loss because there is something called eddy current. Eddy current means uh, when a current passes through a metal, then since metal is a good conductor, it provides very less resistance, so current suddenly increases. So H is equal to I squared RT. One formula is there. I increases means heat produced also increases. So in order to increase the length or decrease the current which is formed inside this, which you call as the eddy current, they will make it into thin sheets, and each sheet will be laminated from the other. Laminated means they will paint something with a non-conducting paint, so almost like an insulating paint. So that is what they mean by lamination. So in order to reduce the power loss, lamination is done. The lamination uh, is having any defect, then that the transformer will become hot, become it will lose heat energy and will become hot. So that is question number 34. And question number 49, uh, an RL circuit is given. See, RL normally we learned about LCR. So you can either have LC circuit, CR circuit, RL circuit. So in specimen paper, one RL circuit is there. So in RL circuit means one resistor and one inductor only. Okay. So RL circuit, uh, if you draw the phasor diagram, you can see voltage. If the voltage across resistance is like this, then voltage across inductor will be at 90 degree to it. So that's the first thing. And they are saying the net voltage in the circuit. So I am said I did this for individual one. Okay, if only R is there, voltage and current will be like this. If only inductor is there, voltage will be like this, current will be like this. But this is a combined circuit, so the net voltage will be at an angle of phi. So the same circuit I can draw like this. So this will be resistor, this will be XL. If I plot it like this, this part will be XL and this is phi, and this will be the impedance. So I can already they have given theta. Theta is equal to tan inverse of 3 by 4. So tan theta is equal to 3 by 4. Okay. Now tan theta is opposite side by adjacent side. That is XL by R is equal to 3 by 4. They have asked you to find out what is XL. So simply multiply. R is already given as 40. So XL will be equal to 40 times 3 by 4. That will be 30 ohms. And next part of the question is what is the net impedance of the circuit. See, net impedance means I told you is that root of R squared plus XL the whole square. So what it will be, root of 40 squared plus 30 squared, so you will get 4600 plus 900, so it will be 2500. Root will be equal to 50 ohms. Okay. Then they have asked you what will be the current in the circuit. See, current, we know Ohm's law, V is equal to V by I is equal to R. This is only for a resistive circuit, but this is a combined circuit. So instead of so I can add V by R. Instead of writing R here, I should write V by Z. Okay, Z is 50. The applied voltage is 100. They have already given. So I will be equal to 100 by 50. It will be equal to 2 amperes. So I think one more part is there. That is what is the frequency. See, frequency you can find out from here. XL is equal to 2 pi f. That is 3 by 4. So you find f. Not 3 by 4. It is 30. ohms. So you find F. So you will get it is something related to 50 hertz. So hope you understood what is actually going on here. First equation, you must know what is happening to the voltage and current when it is a resistive or inductive circuit first thing. Then you should know what they mean by this phi, etc. Okay, even in an LCR circuit it will be like this. Only difference will be this end will be XL minus XC, and this will be Z for an LCR circuit. Then obviously this time this things always comes in, that omega things always comes in. How to find frequency? I think you understood what type of questions is asked from the AC part. Now see a question is just so, using an AC voltmeter, the potential difference in an electrical line in a house is read to be 234. So a house reads, voltmeter in a house reads the AC voltage to be 234 volt. Okay, if the line frequency is known to be, frequency is 50 cycles, 50 hertz, 50 cycles per second, so 50 hertz. Okay, number of cycles per second is frequency. The equation for line voltage is 165 sine 200 pi t. Options, okay, 331 sine 100 pi t, then 234 times sine 100 pi t, so, and 440 sine 100 pi t. See, such options will give. The voltmeter measures 234. What do see? I already told you the voltmeter. Any instrument which is measuring, it will be measuring the VRMS. Okay. Now this equation is V is equal to V0 sine omega t equation. Now V0 and VRMS, how will you relate it? VRMS is equal to V0 by root 2. So you first find V0 value using the VRMS. That is 234 times 1.414. You will get something related to, you just check out how much it is. Then omega is equal to 2 pi f. 2 pi times f is given 50, so 100 pi t will come. So only thing is whether it will be 165. Obviously it won't be 1 by 65 because root 2 times you are getting 234. Okay, so such questions make from the AC part. Hope you understood what AC part is. I will send you some 10 to 12 questions, one page. Then please try to solve it, and better you solve it today itself and complete this AC today itself.